so next example. We've got this triangle here, same instructions, solve for the missing pieces. Now real quick, look at the missing pieces here, or what we know and what we don't know, and compare it to this one over here.
They're relatively the same.
They are.
Do we have an angle of 23 degrees right here?
Yeah.
Is the side opposite 7? We've got another side of 10, another side of x, and two angles A and B. That's interesting. So what are we going to do? Well, let's get solving. So what do we know? We know this. We know the same thing. Sine. Try not to run into the house. Let's see. We got 7x 10 and 23 degrees. Make sure I'm putting this right. 23 degrees with this side. Side of x with an angle of B. Yeah. Side of 10 with an angle of A. So, how are we supposed to not get the same answers then? It's interesting. Well, what should we do first? What did we solve for first last time? Angle A? Let's do that. So angle A, we've got 7 over sine 23 equals 10 over sine A. What do I do next? Cross multiply. So we've got 7 times the sine of A equals 10 times the sine of 23 degrees. This is not looking very promising, is it? We're going to end up in the exact same place, right?
Yes.
Cancel. Sine of A equals
0.558.
thank you, 0.558. And what do I do next?
Inverse sine.
The inverse sine. You think it's going to give me the same answer this time?
Yes.
Inverse sine. And hey, what do you know? I get 33.93 degrees. What's the problem? Look at angle A.
You have to switch it because that's
It's greater than 1.
Switch
It's
it.
greater than 90.
Yes.
It's in the second volume.
It's greater than 90, so you got to switch it using the technical terminology. This angle is greater than 90 degrees. It's an obtuse angle. You guys remember from a while back, all students take calculus, which functions are positive in which quadrants. Sine of some angle gives us a positive number. So, remembering your organic brain, not just being a monkey punching buttons on the electronic brain, we know that an angle in quadrant 1 or quadrant 2 will also give us a positive for the sine function. So clearly, 33.93 degrees is going to be the quadrant 1 angle. But looking at this, we obviously need the quadrant 2 angle. So we need to find out what this angle over here is. Blue. We need to find this angle here. So have the same bow tie or relative angle here, reference angle here. We need to find this one because this is going to be what A is in this triangle. So how do we do that?
Subtract 180. Or
Here's the atom.
subtract that.
Subtract 180.
Exactly. So 180 minus this angle is going to give us what?
156 degrees.
So angle A is actually, in this triangle, for all the exact same setup, except when we get to this step, we have to use our organic brain to make the adjustment to quadrant 2, so that we do 146.07 degrees instead of 33.93 degrees. And from there, we can go on and get the other ones. Actually, the rest is going to work out the same way, except what's going to be different. This part right here, it's still a triangle, still has 180 degrees, except now we're subtracting 146.07 and subtracting 23, which leaves what? That's right, 10.93. Were you even following along with the calculator? One of you, excellent. Makes me feel real good. All right, so this one here is going to be angle B. So we have angle B here, angle A is this one, and then we can fill in for side X, which we're going to get a different answer now because we have a different angle that we're plugging into the equals x over sine of b, but this time b is 10.93 degrees. That's a 3, in case you were wondering. Again, cross multiply, and we've got x times the sine of 23 degrees equals 7 times the sine of 10.93 degrees. And this is where you have to make sure you have your calculator handy, and you know that it's in degree mode. I know I said that already, but I'm saying it again because it's easy to forget. Cancel, cancel, and x is going to come out to, let's see,
3.39.
that one. And I beat me to it. So x is going to be 3.397. I'm going to round it to there. Tanner said 3.39. Is 3.39 and 3.40 close enough? Yep. And so now we have the three missing pieces, side x, angle A, and angle B.